Today, we will learn about how to name acids and bases. But first, we're going to see if you guys can figure out the rules yourself before we tell y'all. So let's dive into these models. Our first model deals with binary acids. Binary acid is simply an H plus one other element. And from our example, we see we have a hydrogen with a chlorine, hydrogen, bromine, hydrogen, sulfur, hydrogen, fluorine. And then let's look at the names. For HCl, it is hydrochloric acid. For HBr, hydrobromic acid. H2S, hydrosulfuric acid. And then HF, hydrofluoric acid. So there seems to be a trend there. We have cations listed and the anions listed. Okay, so let's go over some of these questions together. What is the same about all of these acids? So they all have hydrogen. Their names all end in acid. They all start with hydro. What is different? Well, the anions are different. And then this H has 2 in front of it. And that leads to question number 3. Why does hydrosulfuric acid have 2 H plus while all the others have 1? So if we take a look at the charges, y'all, all of these guys cancel each other out. Even hydrosulfuric acid, we see there's no overall charge on that molecule. So the 2 distributes to that positive charge, creating a positive 2 charge to cancel out that negative 2 charge. So that's where the 2 comes from. However, it doesn't look like that 2 affects anything within the name. So number 4, can you come up with 3 naming rules for binary acids? So think those through, find an empty page in your spiral, and try to write those rules down. So model 2 deals with ternary acids or oxyacids, an acid that has H plus a polyatomic ion. So taking a look at that, y'all, polyatomic ions are listed here along with their polyatomic ion names. Taking a look at a couple, hypochlorous acid, chlorous acid, chloric acid, perchloric acid. So it seems to correlate with their polyatomic names. It has every single acid ending in acid, and yeah, it just looks like their endings are different. Right? We have ic and us for every single one of them. Okay, so if you guys forgot the polyatomic ions, let's take a look at the next slide. So these were the polyatomic ions that were given to y'all first semester, and if you guys forgot, here it is again. I would write them down somewhere in your spiral if you guys can't remember them or lost your first spiral. So here they are. So questions to think about. How are ternary acids different than binary acids? So definitely it contains more than just one other element. It has 2 in some, it has 2 for all these cases here, an element and oxygen. What relationships can you make between the name of polyatomic ion and the name of the acid? So it looks like they start off, each one of them start off with the beginning of the polyatomic anion name, right? So hypochlor, and then the chlor for the chlorite, chlor for the chlorate. And if we take a look at the endings, y'all, ite and ate, it looks like it has a trend. Let's see if it's true for the others. Chlorochlorate looks like it ends in ic. Sulfite ends in us. Sulfate ends in ic. Phosphite ends in us. Phosphate ends in ic. Nitrate ends in ic. Nitrite ends in us. Carbonate ends in ic. So there seems to be a trend there. Okay, so finally, can you come up with the 3 naming rules for ternary acids? 3 steps in order to get this name here. Last but not least, Model 3, bases. So we have 4 bases here. The name for each of the base listed: lithium hydroxide, rubidium hydroxide, barium hydroxide, cesium hydroxide. The cation and anion are listed as well. Let's answer some questions. So what is the same about all these bases? They all seem to have hydroxide, and then their names end in hydroxide. What is different would be the cation that is attached to the hydroxide. Why does barium hydroxide have 2 hydroxide ions while all the others have 1? So that 2, again, we don't see an overall positive or negative charge on the base molecule. So that 2 distributes at -1, and it cancels out that charge on barium. So can you come up with 2 naming rules for bases? Looks like the elements stayed the same in the name, no changes there. And hydroxide just stayed hydroxide. Seems pretty easy. Okay, y'all, let's dive into today's lecture.